Now that we know what complex numbers are, we can start looking at operations with them. I'm thinking of the basic arithmetic operations: addition, subtraction, multiplication, and division. The only thing that you have to keep in mind when calculating with complex numbers is this single rule that I, the imaginary unit, squares to -1. So this is the only thing we have to keep in mind, but it's very important when we are calculating with complex numbers that we have this in mind. Okay, the rest of the calculations will be just like with real numbers. So for me to be able to talk about these operations, let me introduce two arbitrary complex numbers. The first one is z1 in the form of x1 plus y1 times I, and z2 in the form of x2 plus y2 times I. Okay, and let's start with addition. So the sum of z1 and z2 is, of course, well, z1 and z1 plus z2, but the way we calculate this is we write these numbers out: x1 plus y1 times I plus x2 plus y2 times I. And what we'll do to get the sum is we'll add the real parts to get the real part of the sum. So it will be x1 plus x2, and the imaginary part of our sum will be the sum of imaginary parts, so that is y1 plus y2 times I. So this is how we add complex numbers. Let me give you an example, a concrete example. So let's consider the numbers 7 plus 8i and -2 plus 1.5i, and I want you to add these numbers. Okay, pause the video and input your answer in the box below. Okay, I hope you paused it and found that the real part of the sum is 7 plus -2, and the imaginary part of the sum is 8 plus 1.5, so that is multiplied by 1, so the answer should be 5 plus 9.5i. Okay, I hope you got it right. Let's move on to subtraction. Okay, the difference of z1 and z2 by which I mean taking z1 and subtracting z2 from it. Well, it will be very similar to adding two numbers, but there will be a very important sign change. So x1 plus y1 times I, and we subtract x2 plus y2 times I from it. We'll do the same that we did with addition. We'll take the difference of real parts to get the real part of the difference, and we'll take the difference of imaginary parts to take the imaginary part of the difference of these two numbers. So we'll get x1 minus x2 for the real part plus y1 minus y2 for the imaginary part, but this has to be multiplied by the imaginary unit I. Okay, again, let me consider an example. So I want you to take the difference of the numbers 2 plus 5i and 3 minus 5i. Take the difference of these two numbers and use the box below to input your answer. Okay, I hope you paused the video and did the calculation and found that the real part of the difference should be 2 minus 3, and the imaginary part of the difference should be 5 minus 5. This is multiplied by I, of course, so your answer, I hope, was -1 plus 10i. So this is the difference of these two numbers. I hope you got it right. Let's move on to subtraction, that is multiplication. So far you might have noticed that we didn't use this relation I squared equals -1 anywhere. Now this is the place where we are going to have to use it to calculate the product of two complex numbers, z1 and z2. It will have the following form, the product of z1 and z2. So it's z1 multiplied by z2. We will simply write these numbers out in this form, x1 plus y1 times I multiplied by x2 plus y2 times I. And what we'll do is we'll simply expand this product to get x1 times x2 from this product, then x1 times y2 times I, then x2 times y1 times I, and finally x1, that is y1 times y2 times I squared. We have two factors of I in that last term. So let's just collect the terms contributing to the real part of the product. This is such a term, this is a real number, x1 times x2. And there is also another term that is real, that's the last term. Here we have to use the fact that I squared is -1, and if we do that, we get minus y1 times y2. This is the real part of the product of these two numbers, and the imaginary part will consist of the sum of factors multiplying I. So one such factor is x1 times y2, and the other factor is x2 times y1, and these multiply I. So this is the product of two complex numbers, and let me give you an example. So let's consider the complex numbers 1 plus 3i and multiply that by 4 minus 5i. Okay, so pause the video, calculate this product and input your answer in the box below. Okay, I hope you have paused the video and got the following answer. So when we multiply 1 by 4, we get 4. When we multiply the terms containing I, we'll get -15 I squared, right? Then when we cross multiply, take the cross terms, that we get 12i, and we also get -5i. So what the answer is, we have 4 minus 15 times I squared, which is -1, so that is plus 15, giving us 19. This is a sum, and then we'll have a total of 7i if we calculate that. Okay, so finally I want us to look at the operation of division. So we're going to divide complex numbers. So the ratio of z1 and z2 is the following. Well, now we have to divide z1 by z2. And this is where things get a bit tricky. We have never divided by a complex number. We don't know how to do that. That is the whole point. But what we have done is, what we know is how to divide by a real number. So what the trick that we'll do is we'll introduce an extra factor, which is just 1, but we introduce it in such a way that it is going to give us a real number in the denominator. So what I have written here is the complex conjugate of z2 divided by itself. So that is just a factor of 1. It's not going to change the result, but what it will do is it will turn the numerator into this product of z1 and the complex conjugate of z2, and the denominator will be z2 multiplied by its own complex conjugate. And if we do calculate these products, so let me just write these out. x1 plus y1 times I is multiplied by x2. Remember, complex conjugation means a sign change for the imaginary part, so it's minus y2 times I, and it's divided by x2 plus y2 times I times, again, x2 minus y2 times I. And what we'll get if you use the formula that we have obtained for the product of two complex numbers, if you use this formula to calculate both the numerator and the denominator, what you will get is the following. It will be x1 times x2 plus y1 plus y2. This is going to be the real part of the numerator, and the imaginary part of our numerator is x2 times y1 plus, that is minus x1 times y2 multiplied by I. And what we are dividing by is very important. If you calculate this product in the denominator, what you'll get is a real number, and it's the following real number: x2 squared plus y2 squared. So that is very important, that x2 squared plus y2 squared appears in the denominator because we have used this trick, and that is a real number. We know how to divide by a real number, so the ratio will have the real part, x1 times x2 plus y1 times y2 divided by x2 squared plus y2 squared, and the imaginary part of the ratio will be x2 times y1 minus y1 minus x1 times y2 divided by x2 squared plus y2 squared. At this point, I should also note that we are dividing by a real number, but we shouldn't be dividing by 0, and this expression is 0 only if z2 is 0, if and only if z2 is 0. So we should say that z2 is something other than 0. So it's not entirely arbitrary when we are dividing by z2. So division among complex numbers is similar to division among real numbers, where we have where we cannot divide by 0. Okay, so the final example I want you to consider is the following. Okay, I want you to consider the following ratio of complex numbers: 2 plus 6i divided by 5 plus 3i. Okay, and I want you to pause the video and calculate this ratio and use the box below to input your answer. Okay, I hope you paused the video and did the calculation. What you should have gotten is 14 over 17 plus 12 over 17 times I. Okay, I hope you got it right, and I'll see you in the next one.